All right, folks. Thank you for coming to the AWS Sports with User Group tonight. Tonight, I'm very excited to present to you Kunal Batra. He's been a longtime friend of the show. And we're going to do a reInvent recap. He's going to cover all of the events of the previous 2019 AWS reInvent. 5 days worth of topics in 45 minutes or less. So again, thank you to HashiCorp for the pizza that we're all eating, and thank you to Seaglass for the gift cards that we're going to have tonight. We're going to do the electronic survey.
Yep. Yeah,
So we're all out of the paper.
Yeah.
Okay, we're going to do the electronic survey tonight. So awspug.org/survey, and at the end, and then we'll run the generator and see who the winner is. So we won't be able to do the drawing and taking the draws anymore. So.
Yeah, it won't be ranked anymore.
Well, you know, we just get paid off and just give it to somebody else. So without further ado, Kunal.
Perfect. How's everyone going today? So my name is Kunal. This is going to be the reInvent recap compressed. It's only have about an hour. This is probably one of the most different talks I've ever given. Usually there's a beginning, a middle, an end. There's a narrative. Today's just going to be about shiny things and just like different services talking about it. So if things feel a little weird, that's because they are. Just to calibrate any conversations that we have during this or afterwards, just a little bit about me. I'm a senior technical evangelist here at AWS. I've worked on a lot of different developer-focused products. I'm also really into computer vision and machine learning. I built an app that my parents absolutely love. It lets them know whether the garage door is open or closed. They always forget, so they're in love with that. Another one over here where I count how many people are in line at the Shake Shack in Madison Square Park. If you have any questions at any point, need extra AWS credits, anything I can help out with, the fastest way to reach out to me is my Twitter handle, @Kunal732. My email's right below that as well, but if you want a quick response, @Kunal732 on Twitter. And last, I just built this. I'm really proud of it. I tend to lose my Nintendo Switch Wiimotes a lot, so I built an object detection model with one of our services here, so it'll always know where my controllers are at any point.
Using recognition?
Using SageMaker.
Okay, nice.
Yeah. All right, so this is the website for reInvent. It sounds like a lot of people here were at Vegas. Just in case you weren't, you can go to the website, which is reinvent.awsevents.com. You get to see a lot of the keynotes. You get to see the actual reInvent recap, the whole presentation with the band and everything, which I don't have today, next time. So that's the website again. Again, that's reinvent.awsevents.com. And you can see it's a pretty big website. There's a lot of talks up there. So definitely spend the weekend with that. And again, when I usually give a talk, there's usually an agenda, beginning, a middle, end. The agenda today is going to be lots of services. So let's get started. The first thing we're going to start off with is compute. A couple years ago, AWS acquired a company called Annapurna Labs based out of Israel. And we kind of split them into two different teams. And one of the teams built the Graviton instances. And this year at reInvent, we introduced the Graviton 2-based instances. And you can see we have 3 different variations. One's available right now. We have the general purpose Graviton 2 instance. And then you have also the new compute-intensive and memory-intensive instances coming soon. These are ARM-based processors. The idea here is the price-performance ratio. We want to make that better. And this has a 40% better price-performance ratio than x86 processors. And by the way, this is a small group. If you have any questions, feel free to ask. If I know the answer, I will. This also has 7 times the performance of the previous generation of the Graviton 1 processor, 4 times the compute cores, 5 times faster memory. Now, the second team at Annapurna Labs, we had them build out the AWS Inferentia chip, right? So one of the things we've heard from our customers was that machine learning is great, training is expensive, but that's not the cost. The cost is when they make inferences and predictions. And so with AWS Inferentia, they don't have to use those GPU instances for predictions anymore. They can take advantage of this newer chip. It has definitely lower price points and also higher throughput than the GPU instances. The next thing that's kind of exciting, I want to play around with this, I can't wait to play around with this, it's our quantum computing as a service, fully managed quantum computing. The name of it's called Amazon Bracket. I had to look this up, why Bracket. Bracket is actually notation for quantum states. So they named it Amazon Bracket, and that was the reason for that. 3 different types of hardware you get to play around with: D-Wave, IonQ, Rigetti, and I think this is really early on. We're still trying to figure out what those use cases are for this, and we're trying to make that open for all developers to play around with and really understand about that. We've also created a solutions lab where customers can ask experts different questions on what the best ways are for quantum computing and the best practices for that. So moving on to management tools, we have Compute Optimizer. Compute Optimizer is an interesting service. It uses machine learning, and basically what it does is it takes a look at your current workloads. As soon as you opt in, it can take up to 12 hours to see your current utilization metrics, and then from there it will give recommendations on what are the optimal, best different types of instances you can use to, for your workloads. Savings plans? Yes.
Quick question about Compute Optimizer. Is that different from the resize recommendations that Cost Explorer give you, or is that what's the use case for that?
So I'm not sure about the resize recommendations. This is using machine learning, taking a look at your utilization metrics. Based on your workload, from there it's going to make recommendations based on what it's seeing.
Recommendations for what?
The best different types of compute instances for your workloads.
But not from a cost perspective, from a utilization.
From a utilization perspective.
Okay, I see. Okay,
yes.
all right.
Yeah, not from a cost perspective. The next service is savings plans. This gives you up to 72% savings on your instances, on your workloads. You need to make a 1 to 3 year commitment measured in dollars per hour. And then from there, regardless of instance family, size, region, you get those savings. Questions? Okay, EKS for Fargate. So now you don't have to manage the underlying servers for your EKS clusters. You can go ahead and use Fargate for that to make it a little bit more serverless.
There was like a discount on EKS, like when that was recently, is that like dovetail with this?
Are you talking about the spot?
Yeah, it was like 50% off for EKS.
I'm not sure.
I saw that too.
So, wait, you saw that for EKS for Fargate, or you just?
No, not for Fargate.
Okay.
Like a recent
newsletter that came out.
Okay, got it. Well, I'll find out, let you guys know. So that was compute. Now we move on to container support, extending AWS beyond the region. So some interesting announcements here. We have container support for AWS IoT Greengrass. Essentially, this just means that you can now take your containers and move it closer to the edge, or move it to the edge, and deploy your applications there. And now we have AWS Outposts. How many people here have heard of Outposts? Did you guys see the Outposts? Have you seen the actual servers?
Yeah.
No? Yes? So essentially with Outposts, let me show you a photo. This is a photo taken at reInvent. We give you the actual servers and racks, we bring them over to your site, and then you can run AWS infrastructure on your own at your site. From there it comes with a bunch of computing services, ECS, EKS, S3 coming soon, and also EC2 and EBS as well, that's not listed over here. So this has 2 different ways of managing it. You can use the native AWS way, or you can use the VMware control plane as well to manage it. Local zones. So there are lots of applications that our customers have where they need single-digit latency. So this is either financial companies, media companies, it could be for video games. So what we did over here at AWS was bring our infrastructure close, local to different cities, hence the name local zones, to give that single-digit multi-second latency. And we've done it with 2 other ways as well. So this is local zones. The next thing is wavelength. So wavelength is where we brought our infrastructure to Verizon and other 5G providers so that your mobile devices can also get that single-digit multi-second latency. So first thing we're working with is Verizon, then Vodafone, KDDI, and then SK Telecom.
So where does one of these smaller ones, like what makes it not a region or an availability zone?
For the wavelength?
What was the service right before?
Oh, local zones.
Yeah.
So we bring the compute resources right next to cities, right? So first thing we're starting off with is LA, and then we're going to go city by city, start with major cities, and then kind of going smaller from there.
Yeah, I guess, like, I'm trying to understand a little bit more, like, what's the difference between, you know, US East 1, right? I guess we don't necessarily know exactly where all of those are, and you're saying now, you know, this is going to be in LA. Is that kind of, what makes it smaller than a region, per se?
So I think it's not about the size of it, it's about the closeness of it, how many hops away to it, right? So the whole goal of this is to reduce that latency for those media companies, for those financial companies, for those video game companies. So it's more of the proximity, yeah. And then same thing goes with wavelength, that sits in like Verizon's infrastructure, other telecoms infrastructure. All right, next is AI and machine learning. So the way we think of AI here at Amazon is in these 3 stacks. Has anyone seen a slide like this before? Ever seen this? So 3 stacks. The bottom stack over here is the data scientists, advanced machine learning practitioners. Over here you see the frameworks and you see the infrastructure that helps them power their applications. In that middle stack over here is SageMaker, right? So SageMaker is a service we announced back in 2017, reInvent. And this is kind of an orchestration tool that makes it really easy to build, train, and deploy machine learning models. And so we've introduced a couple of services, which we'll talk a little bit about in a second. And then the top stack over here, this is for every developer. You don't have to have machine learning expertise. You can take advantage of any of those services over here just by using the API. They're a lot of fun. We did a video of one for recognition. It's online right now. What's the?
On the V Brown Bag website.
V Brown Bag.
Yep.
So before reInvent, we're going to talk about those top level AI services. We had some pre-reInvent highlights. So we have Comprehend, which is natural language processing. We can now understand 6 additional new languages. We can translate 22 additional languages. Transcribe a speech to text, 15 additional languages as well. You can see the rest of the pre-invent updates over there. This one is interesting. For transcribe medical, you can now, doctors can now just speak what they're saying to patients. It'll automatically transcribe it. It'll understand different types of medications, usage, doses. It'll automatically understand all of that. So you don't have to write that, it'll pick it up perfectly. It also does this live transcriptions as well. I showcased that little picture over there of the garage door open or close in the beginning of the presentation. When I built that, I used SageMaker to go ahead and build that service if the garage door is open or closed. We just introduced a new service in reInvent, recognition custom labels. So you no longer have to actually use SageMaker to build that model. You can just drag and drop a bunch of photos of the garage door closed, a bunch of photos of the garage door open, and automatically create your model. It's really simple, really easy to use. I definitely recommend checking it out. Another service that we just launched, Amazon Augmented AI, and this is interesting. Every time you make a prediction with your model, if the accuracy is really low, it will then not send that prediction to your customer, it will send it to a group of humans, which is Mechanical Turk, and they then will just verify what the actual answer is and then send that to your application. So here's a little diagram showcasing how it works. If the accuracy is low, it'll go to the humans to predict it, which is the Mechanical Turk, and then it'll store that result, otherwise it'll send it back to your application. So this is the view from the Mechanical Turk perspective. They'll see this question, which sport is being played, they'll choose the correct one over here. So you'll always have, your customers and your application will always have those accurate results. There's another example over here of taking a look at a form and you want to verify that your application is picking up the text correctly. You can see it's not. The actual name is Jane Doe. Your application picked up Jane Dunn. So now that human will come into play, they'll go ahead and correct that and send the accurate results back. Another interesting service here is Amazon Fraud Detector. This is pretty self-explanatory, but what we do is take the knowledge we've gained in the last 20 years with Amazon.com and open that up for our customers. So if you're building an application that requires any sort of fraud detection, whether it's an e-commerce store or anything like that, you'll be able to take advantage of this. The way it works, you bring in your training data, data you have from your website of maybe some fraudulent actions that occurred. From there, it'll go ahead and take it through a whole process for training it automatically without you having to do anything. And you'll have a custom model that'll let you know whether there is fraud happening or not on your website. Some domains is online identity fraud, payment fraud, new account fraud, account takeovers, promotion code abuse, and then seller performance evaluations. This is a fun service. This is AWS Code Guru. So this thing, it does two things. Right now it's only for Java, and it will give you automatic code reviews, as well as detect and optimize expensive lines of code, and identify any types of code that are giving you latency and performance improvements. Right, so there are two separate applications over here. Java for now, and here's an example. Basically, it can take a look at a block of code, it can see what's wrong with it, it'll give you recommendations, as well as link back to documentation and how to improve it. And then for the profiler, it'll take a look at the code from here and say, these lines are expensive, they're causing latency, here's the issue, here's the fix. First, you do Python or Java? Or
Python.
Python? So it's not there yet, it'll be there soon.
When you say do Python, that's a very strong term. I dabble.
Dabble. Another interesting service that we introduced is Amazon Kendra. This is enterprise search. Basically, we had a lot of customers come to us, and they have a lot of different sources for their data, and they wanted to easily create an internal search engine that can search all these different types of data, whether they're documents, photos, images, whatever they are. So this is Amazon Kendra as a solution to that. It comes with a bunch of connectors, and essentially what you do once you want to set up Kendra is you start pointing it to where your data is stored, whether that's S3, different databases, Google Drive, Box, wherever your data is stored, you point it to that. It will then go ahead and inspect and index all of your files and give you the ability to search on that. So here's an example of the interface. You can see in the top over here, when you want to search for something, you can just use natural language. You can just type it like you speak. Over here is when is reInvent. It'll give you the top link that it thinks is correct. From there, it's also constantly learning. So you can see it has that thumbs up, thumbs down over there. So you can give it feedback. It'll learn how it's doing over there. It also learns based on what you're actually clicking. So if whatever it's picking up is not in the first page, maybe it's in the second page, and you're clicking on that, it'll know that it's doing something wrong, and it's going to learn from that. So some of the machine learning services, and before we go, do we have any ML practitioners here? So this is all new for everyone? That's perfect. Okay, so SageMaker, again, this is a service that makes it easy to build, train, and deploy applications, right? And one of the things developers have told us is there's no IDE for this. When you're developing code, you have an IDE that makes your life really simple. With SageMaker and with your machine learning models, that doesn't exist. So we created SageMaker Studio to put everything you want in one pane of glass. You can be able to check how your experiments are doing, how your machine learning model is training, how you visualize it, debugging errors, all in one pane of glass to make it easy, and this is how it looks like. So from here, you have the ability to see how your models are doing, you have the ability to visualize it, the ability to just understand what's going wrong, what's going right with SageMaker Studio. And then we also have SageMaker experiments. So in machine learning, it's not that you just give it data and it learns from it. It's an iterative process. You're going to give it data, you're going to see that it's not working, it's not accurate, you're going to start from the beginning again, maybe get new photos or different types of data for your application to make it more accurate. So this is definitely a repetitive thing, and with experiments, it lets you see how that's going. So this is just a little visual view to showcase that. And now this is one of my favorite services. This is also great for people who are new to machine learning. SageMaker AutoPilot pretty much does everything for you. Like, you don't have to do anything. You can just give it an Excel sheet or some tabular data, and you can say, I want to predict on this column. And then from there, it'll tell you, it'll just create the model, it'll work with your data, it'll do everything for you. And at the end of it, it'll tell you what it did, but you don't have to do anything. It essentially takes data scientists out of the picture. It is a fun service to play around with. Right now I'm doing something kind of cool with it, at least I think it's cool, but there's a field of security called keystroke dynamics, and it's really interesting. Basically, by the way you type, so you don't need a password, it's just by the way, you are the password, the way you type is the password, right? And you're looking at how long you press the key down, key up, and the spacing between different keys. And you just collect that data and you can put it in here and you can say, this is Kunal, this is Chris. And then for the future, it'll just know, okay, when you type like this, okay, Kunal's on the keyboard, Chris is on the keyboard. Or take and do whatever action you want with that, maybe add that as another security factor. You don't have to do any real code with this. It'll automatically just figure that out for you. Pretty cool with that.
No more sharing keyboards.
Pretty much. But it's just something fun to play around with.
So is the IDE like a desktop app, or is that like
It's
in
online.
the browser?
It's in the browser.
Browser open.
Yeah.
That's a good question.
Yeah.
What languages? Obviously Python.
Python is the big one. Yeah. Yeah.
Does it have like TensorFlow like built in, like you have the low level, not built up, but you have access, like you're running the Python,
Yes.
basically Python?
Yes, you can
environment?
choose between MXNet, TensorFlow, whichever framework that you're like comfortable with, and then from there you can just start writing code and start just making it happen.
And how does that autopilot, how are those models as far as performance compared to, those who were trained at a lower level?
So, they're good. They're good. So AutoPilot takes into consideration, it does something called AutoML, right? And AutoPilot is just a little bit different. It does everything automatically for you, but it's not a black box because it'll tell you what it did, right? So it's accurate, and it'll also tell you how it got to its conclusions. Typically the problem with AutoML is that it gets a pretty accurate model, but you have no idea what happened. It's a total black box. So with AutoPilot, it tells you there's a lot of concurrent things. It's pretty much just testing out everything. It's creating like a bunch of models, just a lot of parallel processing to get you that right result and figuring that out for you. And this is a little chart over here. When you want to build a machine learning model, first you got to figure out what that problem is, right? So the problem I just mentioned is, if I'm typing on your keyboard, how do you know who's typing? You got to figure that frame. You got to collect that data. You have to go through this process, and if it's accurate enough, that's great. If not, start over again, right? So it's definitely a repetitive process. With AutoPilot, everything with a star here is automated for you. So you have to worry about the machine learning problem that you want to frame, how you're going to collect that data, piece that data together, but then everything else after that is all pretty much automated. So the next service is the Deep Racer. And I know a lot of people here are familiar with the Deep Racer. It's over here. This is the first generation of the Deep Racer. We introduced a new Deep Racer this year at reInvent, and it has some pretty interesting additions to it. So I'm going to take off the hood of this. So right now in the original Deep Racers, I'm sure you guys are familiar with, you have that single camera over here. And this is its view of the world. This is how it senses what's happening by that camera over here. In the new Deep Racer, there's two cameras, right? And this gives it stereo vision, can help with depth sensing as well. The purpose of the Deep Racer, again, is to showcase a type of machine learning that we have at AWS, which is called reinforcement learning. And reinforcement learning is just learning through the consequences of your actions. So right now, this car can learn just from that one camera. The new car has two cameras, and also has LiDAR as well, right? So it can have a 360 view of what's happening around it, which is great for racing. Because right now, when you race, it's pretty much just a time trial, and you're just trying to see how fast you can go around the track. With that new car, you can race multiple cars, and also have object avoidance as well.
How much is a new car?
I don't know the price.
It's not on the market yet.
But they also have an update kit coming, so you can modify your old car.
Oh, nice.
Yeah, because the old car, you can still see it has 3 USB ports, right?
Right.
So you get extensible. There's actually another one over here as well.
So you'll get another camera, the
You get the
LiDAR
hood.
sensor, and a cowl for the system.
Exactly.
Cool.
Yeah.
Have to throw them out.
You're gonna throw them up? No, there's similar races of this one.
There's a little video of the new one. So So there's going to be 31 races this year with the Deep Racer. I think that's 8 more than last year.
It's nice.
So I'm going to switch over to browser, and I had this open for a bit. So right now I'm training the new Deep Racer. This Deep Racer, you can see that little blue angle around it. That's the LiDAR. It's sensing what's happening around it.
Your car's a red car?
The red car, yeah. I was kind of evil, and I made a bunch of other cars go around the track at like the fastest speed possible.
So it's going up
they're
the
definitely like
rails.
bullying the red car, for sure. But so it's learning. I just started this training process right before I got here. But whenever the car stops like that, either the Wi-Fi is bad or it's stopping to train more. So we don't know which one's which, but you can see my car over here. There's 4 other cars that are going around the track. The whole goal of this now is going to get rewarded every time it makes sure it avoids another car. So after a while, in this case, I'm setting to train for 8 hours. From there, after that, it should be somewhat okay to avoid other cars. I don't know about this particular scenario because this is kind of crazy. They're going really fast, the other cars.
Is there going to be Gen 1 and Gen 2 races, or are the 31 races all going to be Gen 2 races?
They're going to be mixed. So you're going to have the time trials.
Yep.
You're going to have object avoidance. So it's not going to be other cars, just going to be random objects placed around the track. And then you're going to have head-to-head with multiple cars or racing.
Awesome.
Yeah. So that video I was just showcasing before was RoboMaker, which is actual where the world is built in RoboMaker. This is just the actual Deep Racer console, and you can see kind of that point of view up here there.
Was that only available, that video, through the second generation? Because I was part of a team of the first generation, and the view was terrible.
Yeah.
Just got like a first-person view of the bumper, and it didn't really...
So now the view for all cars right now is going to look like this.
Okay.
So you're going to see kind of this top down, and you can see this view here as well.
Was the RoboMaker thing you just showed, was that a video, or was that a feed?
No,
as
that's
well?
a feed as well.
Of the same.
So that's a
same
feed
thing?
of the whole world that it's training in.
Okay.
So if you mess up something in that world, then that's how it trains it.
Okay. So we're looking at the same thing here.
Yes, exactly. Yeah. Cool. Sweet. The next service we're doing. So by the way, I'm about to talk about the Decomposer, but just in case everyone here is not familiar, I have the deep lens right there. I have the deep lens. So back in 2017, reInvent, we introduced SageMaker, right, our machine learning service. And the idea was, how do we make this real? How do we make this stuff actually in the hands of developers? So first year, we created the Deep Lens, where you can create your models in SageMaker, download it to the Deep Lens, and actually do your predictions on the fly, happening right on the device. It's really cool. You can actually see it happen on the device. And this takes advantage of supervised learning for the computer vision. Then obviously after that, in 2018, reInvent, we introduced the original Deep Racer. This past year, we introduced the second generation, as well as Decomposer. So Deep Racer takes advantage of reinforcement learning, supervised learning. The Decomposer takes advantage of something really cool, generative adversarial networks, GANs. Now this is where AI just creates stuff. There's a great website called thispersondoesnotexist.com, where it's just showcases people who don't exist, built by GANs, right? It's just generating people. Now with the Decomposer, this doesn't show you how to build fake people or create fake people, but it shows you how to create music. So let me showcase this. So I'm in the Decomposer music studio, and this is still in preview, but I can go ahead and record a song that I just create, and then the Decomposer service will take a look at that and create something based upon that. So let's go ahead and do this. I am not a music person, Chris, sorry. So guys, apologize if it sounds bad. Let's do this. So that's my song right there, And now let's give it a model. Let's make this a rock song. So it's going to create a rock song based on what I just did. And we say generate composition. So it generated it. And let's play this. That's a little bit better than what I did. So this has been trained quite a bit. Now we're just being able to take advantage of it. This is something called generative adversarial networks. It's really cool stuff. The Decomposer is really meant to just be that basic level where anyone can just start playing around with it, understand what it is, and then from here you can follow the rabbit hole and start getting more and more cool stuff with it.
How do you generate the models? Like can you generate models from like multi-track, like input?
So right now I believe it's just the composer, but I think they're going to open this up so you can add in more stuff in there to generate models from. And
Okay,
if you go to,
so the composer, like you get one block of MIDI that's a single.
Yes. Yeah.
So garage band on steroids.
Pretty much. I believe right now this is in preview, but when it goes off, it'll let you also put your songs on Spotify and SoundCloud.
Elon Musk will love this.
It's a fun service. There's a bunch of, we have a GitHub website too, AWS Labs, so github.com/AWS Labs, where you can kind of break down and see what exactly is happening here. Right now I'm just showing you the UI, but I'll also showcase the code as well. The only thing is right now this is in preview. Once it gets generally available, then I think that'll be available to everyone in the labs.
So is this more intended for people to get into machine learning, not so much for making great music?
Yes.
Or, okay.
Yeah. This is definitely not about the music you'll create with it. Yeah.
Can you elaborate just a little bit about how you go down the rabbit hole? Because I mean, like,
Yes.
like the example you gave is kind of just like
Yes.
a few buttons, but like.
Yeah, so here's the Decomposer page. This will walk you through a little bit about what's happening with the Decomposer, how it's working. You can check out the documentation as well. But what I was mentioning before is the GitHub link over here. It's actually linked over here, so I'll open up a little bit. This will walk you through the labs and how you can custom do what we just did in that user interface, right? So there's two labs that will walk you through it. The first one is with current Decomposer models like the Rock one I just showcased. Second one will be custom.
And there's a physical keyboard with this, right?
Yes.
Is there going to be?
Yeah, there's a physical keyboard with this, but you don't really need it. There's no smarts in the keyboard. That's why there's that MIDI player on the website as well. It just makes it easier for you to use the actual keyboard. Yeah.
You can borrow mine, Chris.
All right, thanks. Neighbors will love it.
You have a composer?
I can bring in my keyboard the next time if you want another raffle item.
Totally.
So that's Decomposer. It's a fun service just to learn about generative adversarial networks. Oh, it's a little video here showcasing this. I think this is a much better example than what I did. Yeah, he's more talented than I am.
Oh, the joy.
So let's go ahead and send that to our rock generative model. In about less than a second, we'll go ahead and we'll generate all of the accompaniments. So here we have a guitar, bass, synth, and drums. Let's go ahead and have a listen.
Yeah, that sounds a bit better.
Yeah.
All right, so that finishes off the AI ML services. Now we'll move on to databases and analytics. So the first service that we announced was Amazon Managed Apache Cassandra. This is currently in preview. We had a lot of customers who used Apache Cassandra. Are people here familiar with Apache Cassandra? They use it? So it's generally used a lot more for write-heavy applications, more write than read, a lot of storing logs and that sort of machine-generated data. We had a lot of people, customers who wanted to switch over to AWS, but we didn't have Apache Cassandra as a managed database. So they had to switch over to DynamoDB or some other solution, but instead we announced Amazon manage Apache Cassandra so they can now take advantage of this. They don't have to create their own EC2 instance and manage their own servers for them. This is fully managed. The next thing is Amazon RDS Proxy. So a lot of applications built on serverless architectures like Lambda, they have a large number of open connections to the database. With RDS Proxy, it lets you pool and share those connections, putting less load on the database and those resources it requires. So
the RDS proxy, they announce only that it's going to be on MySQL and Postgres, and then future they might expand it to other options.
MySQL and Aurora.
Sorry.
Yeah, more MySQL. And in the future it would be expanded. Yeah. So the top right, also you can see whether it's announced, it's generally available, the previews in the top right over there too. I'll also send out these slides as well. So right now, this is definitely a compressed version of these slides. I'll send out the full thing. So
Great.
even in your place, you want to see everything that's launched, we have time to talk about today, feel free to. If you have any questions, again, you can reach out to me on my email or my Twitter handle on those slides as well. Of course, I'll send it to you after.
Yeah, totally.
Yeah. So the next service over here is Amazon Aurora Machine Learning Integration. You no longer have to create your own codes or your own Lambda functions to communicate with SageMaker and then take those results, put it in your database. With Aurora integration, you now have the ability to just get those predictions and either put it in the database for them. All right, so ultra warm for Amazon Elasticsearch. This is in public beta. Basically, this is another tier for Amazon Elasticsearch service. There was a lot of data with Elasticsearch. This makes it cheaper and easier to use by putting that data in ultra warm. So whatever you need to use for Elasticsearch, that will be in the hot tier. Whatever's not being used, you can push that into ultra warm, where you get the cost savings as well for that. Now Redshift, another service over here that's pretty data intensive. The goal with the Redshift RA3 instances over here is to decouple the compute with storage. So right now, whenever you needed new storage, you'd have to open up another instance or add, I believe, concurrency scaling as well. But now with this, you no longer have to do that. Every instance now has managed storage, so you don't even have to worry about it. It'll push the storage down to different tiers to S3 or back up to the SSD based on what you're using right now. And that's Redshift RA3 instances. Any questions so far?
So my question is, I was reading the documentation and announcement for Redshift. It can add the nodes on the fly depending on your usage, right? And of course you'll get charged.
Yeah.
Is that generally available, or that was?
So that was previously available with something called concurrency scaling, I believe.
Yes. Yes.
And so that was announced last year, and that was a way where you can do it on the
No,
fly.
that was, yeah, that was, it would use machine learning and just add nodes on the fly.
Maybe it's a different service then. I don't know if it's using machine
Okay.
learning for that, but it was definitely giving you the ability to add it on the fly.
So now you don't basically, you can just buy one node.
Right, you
And
can
then
take
it
advantage of these
automatically
R3
scales.
instances.
Like previously you were limited by, on your size, right?
Yeah,
And
exactly.
your compute.
Yeah, and now this way you decoupled it. All right, so this is Aqua, which is just a cache that makes searching Redshift 10 times faster. Yeah. All right, so CloudTrail Insights. Does everyone here know the difference between CloudWatch and CloudTrail? Okay, good.
Is there going to be a question afterwards? I think
It's
I
a
do.
pop quiz.
I think it was on the test.
Yeah. Yeah, it's definitely one of the questions on
Yeah.
the certification test.
Okay.
Okay, so CloudTrail Insights, this kind of tells you what's happening with the governance of your AWS account. So based on, you can see if there are unexpected spikes of resources, bursts of IAM management actions, anything that's anomalous that happens in your AWS account, this will let you know and notify you as well.
Can this span account, I can't remember if CloudTrail can span accounts, I know CloudTrail can, but if you had an organization and you wanted to do
Yes,
this
I
across
believe it
multiple-
does work, yeah. Okay, so Amazon Detective, this is something new. I haven't played around with this yet, it's still in preview, but it lets you identify the root causes of any suspicious activity happening on your accounts. So this takes a look at your VPC flow logs, your CloudTrail logs, any guard duty findings, and then it creates a model and showcases, lets you give you more data on what's happening, and what looks weird about that. Another service here, provision concurrency on AWS Lambda. How many people here hate cold starts? So this will hopefully help take away that problem. Essentially, when you have a Lambda function, when you get a request for a Lambda function, it creates an execution environment for your Lambda function. So if you have concurrent Lambda functions, you need concurrent execution environments. And every time you want to start up an execution environment, that takes time. And that's essentially what a cold start is. So with provision concurrency, you can provision a bunch of execution environments in advance, and that way that'll already be warm for you, so whenever you do have other Lambda calls, it'll be quick, there'll be no cold start times.
So what would you recommend? This is something I have a hard time digesting. If that's what I need, if I need all this provision concurrency, why wouldn't I go to an always-on container? Like, is there kind of any balance that you
So the best use case to take advantage of provision concurrency?
Yeah.
It's a good question.
And why not just an always-on container at that point?
That's a good question. I think it depends on your load. You don't want to make sure that you over-provision. You want to make sure that you're using your resources that you need. The cost as well with that. So that could be the main things, but what the best use case for is, I'm not sure.
Okay, because I saw a lot of the early findings, people on Twitter were saying provision concurrency was a little bit more expensive than they would have wanted in their serverless ecosystem.
Yeah, yeah.
And they were seeing, I think the general question is when do you draw the line there?
Yeah, I think one of the reasons for that is you need to have an understanding of how many execution environments you need, which means that you have to have an understanding of what your workload is like, right? So having that, you can definitely optimize for that. This is one way to optimize for that.
Can you change the provisions for certain windows? Can you say, I want more provisions during 9 to 5 and less provisions 5 to 9?
I'm not sure.
I don't know.
Yeah, I'm not sure. Okay, now we have AWS Step Functions, Express Workflows. So Step Functions is a way where you can connect or link together a bunch of Lambda functions. It's actually really interesting. Express Workflows lets you handle loads of 100,000 events per second or more, so definitely for high volume use cases. I haven't used this. I can't think of a use case for this right now for me, but I'm sure there are. And I believe...
Credit card transactions.
Credit card transactions. So I believe it puts us at 45 minutes.
Yeah, just a little bit over.
Just a little bit over 45 minutes. On the tweet, I think you told me it's an hour, so let me try to make this as fast as possible. So the actual deck is a little bit bigger. There's definitely services in more of those areas. If you have any questions in any of those, feel free to reach out. That's the video for it. That's the website for ReInvent. Any questions so far? Perfect. Yes?
Well, so I just want to get a better understanding of the provision concurrency.
Yeah.
So that it seems like there's a disconnect between why that keeps it warm and provision concurrency, which I assume that you get more throughput or whatever. Basically, have more CPU at a given time because it's distributed. Is that?
So with the provision concurrency, you automatically make sure that you have enough execution environments already ready to go.
Oh.
So
Right.
we have to pay extra for that?
Yes, you have to pay extra for that. Yeah. And
So
there's a
that
cost for it.
Uh,
I have the cost written down here.
they're basically running already, so there's no.
Exactly.
Yeah.
Yes, you have that running, and there's a cost for that. So it is 0.15 per gigabit hour for provision concurrency.
So in
and then
addition
I-
to Lambda, this is extra here.
Yeah, so when you set up provision concurrency, you have to set a number, and I believe you have a max of 1,000 execution environments that you can set, and then from there it'll give you the cost of what that's going to be for that. So that is extra.
Is that, are you like kind of promoting this over the task scheduler solution? Like,
I think there's multiple ways. This is not like one's better than the
So
other.
this one, so the keep warm approach, the ping was great, but that was only for your first invocation. If you got to the point where you were scaling and you were having more Lambda invocations, that ping only helped your first Lambda invocation. The provision concurrency, my understanding is that it'll let you have that second, third, fourth
Exactly.
Lambda ready to go
Cold start, yeah.
when that volume comes in, so you're not worrying about the cold start on your fourth, fifth, sixth Lambdas.
Right, up to 1,000.
So from a pricing point of view, if I say just say my Lambda function takes, just for a hypothetical, it will cost me $1, so it will be just $1 plus whatever, 0 point
Per
Right.
execution environment.
per execution.
Yeah.
So I don't pay extra, it's like for Lambda, I don't pay for idle, right?
Right.
No,
For
yeah.
provision,
Well,
I don't have
No,
to pay
you're
for
paying
idle,
Well,
right?
you're
the
paying-
gigabit hour.
Gigabit hour.
Yeah.
For that, and then also there's a duration cost as well. So duration cost is 0.035 per gigabit hour for duration. And so if
it's
you go to the
not-
pricing,
is not like Lambda, it's, I have to provision like it's a continuous.
yes, it's separate, yeah.
No, my question is, suppose in Lambda I pay say $1, just to make it easy, and then this provision is say whatever, 0.15. Do I pay 0.15 if my Lambda function does not execute?
So you have to pay that because you're telling it to have it ready to be warm, right? So
Okay,
if you have a
by
max of
hour.
1,000, you can say, I need 500 ready. I don't know when I'll need that ready. So then you're paying for that.
So you pay 500
Times,
into
yeah,
point
exactly.
one.
Yeah.
Got it. So it's basically like an AC to hourly kind of cost,
Yes.
A
this is
very
more-
tiny.
but tiny, yes.
That's right.
So what of these services was your most exciting update? Was it, I think you said some machine learning you were interested in, but was there anything that
So yeah, AutoPilot for me was like that's amazing. It does everything.
Is that beta or it's GA?
The AutoPilot?
Yes.
I have access to it. I think it's ready to go actually.
Okay.
Yeah, I mean I definitely recommend if you're new to ML, definitely check out the Decomposer. But the AutoPilot, that's pretty cool stuff.
So
And, like,
pre-format your input data, because usually like a drone that's got to get your data between 0 and 1,
Yes,
and that'll automatically munge it for you.
you don't have to do anything for that. You don't have to do any feature engineering. It'll actually take a look at your data. Basically, you just give it a bunch of like rows of data, and then from
Determine
there,
how many layers you need.
it takes care of all of it. Yeah. Well, it's actually doing every process, right? It's doing multiple different types of algorithms, multiple different types of networks, and from there, it's predicting. It's giving you the best result.
Cool.
Great, guys. Thank
All
you.
right, thanks very much.